This is 2016 AMC 10B problem 19. Rectangle ABCD has AB equals 5 and BC equals 4. Point E and F lies on AB so that EB equals 1. Point G lies on BC so that CG equals 1. And point F lies on CD so that DF equals 2. Segments AG and AC intersect EF at Q and P, respectively. What is the value of PQ and EF? So this problem can be solved using similar triangles. Now you should look at this ratio and look at the sides PQ and EF. And notice that they're PQ is on EF, so it's really easy to find similar triangles. Okay, so how do we do this? Well, firstly, without even adding any lines or anything, immediately notice similar triangles. Triangle AEP is similar to triangle CFP. Why? Because, firstly, where are those triangles? Here and here. Firstly, we know that they're similar because opposite angles are equal. And we also know that these two lines are parallel because this is a rectangle, right? So alternate interior angles are equal. Okay, so what this means is that we know that EP over EF or EP over PF is gonna be AE over FC or AE over CF. So what's AE though? AE is 4 because it says that EB is 1 in the problem here. And what's CF though? CF is gonna be 3 because it says in the problem that DF is 2. And we know that this side here, the entire side, is 5. So this means that EP over PF is gonna be 4 over 3. Okay, so what this means is that PF is gonna be 3 over 7 EF. You can imagine that PF is 3x and EP is 4x, and this entire thing is 7x. Okay, so PF is 3 over 7 EF. Okay, so yeah, that's about what we know. But what exactly is okay, so knowing this, let's try and continue to find something cute with QB in it. Maybe we can find QF or something. So how do we do so though? Well, firstly, notice that we might want to find the length of EF, because that's possible. Just draw this altitude here and drop it down, and let's say this point is H. We know that EH is going to be 4, because we know that this entire length, the width of the rectangle is 4, right? So this is 4. And we know this is 2 because since AB is parallel to DC, EB equals HC. So this is 1 and this is 2. So we have 2 and 4 as our legs. The hypotenuse EF is going to be, root 4 squared plus 2 squared, which is root 20. So that is, so EF, we know that, therefore, that EF is 2 root 5. So PF is 3 over 7 times 2 root 5, or 6 root 5 over 7. Okay, so this is 6 root 5 over 7. Yeah, so that's that. And let me just label that. We can also find out EP, but that's not really that important right now, I guess. So to continue to find side lengths, we should, since dropping an altitude here worked, maybe we can try and drop more altitudes, because if we drop more altitudes, these altitudes are all parallel to each other, and parallel lines create similar triangles, which are useful in finding ratios. Okay, so let's say that this line here, so A, B, C, D, E, F, G, H, I, let's say this is QI and PJ. So we want to find PQ PQ over EF, right? Now we can literally see that PQ corresponds to IJ and EF corresponds to FH. So our answer here is actually just equal to JI or IJ over FH. And you can also prove that using similar triangles. We know that the ratio of PF to EF is the ratio of FJ to FH because of similar triangles. And we also know that the ratio of QF to EF is equal to the ratio of FI to FH because of similar triangles. So we subtract the ratios from one another. We know that PQ to EF is JI to FH. Okay, so how do we find JI though? And how do we find FH? I mean, we have FH. FH is just going to be 2. But how do we find JI? Well, let's first try and find FJ. Let's first try and find FJ. Okay, so what's FJ? Well, we know that from similar triangles that PF over E. So PF is 3 over 7 EF, right? So we know that. So this means that since PFJ is similar to EFH, PF over EF equals FJ over FH, just like I just said. So this means that FJ is 3 over 7 of FH. Okay, so FJ is 3 over 7 of FH. And we also know that PJ is 3 over 7 of EH. So what's PJ? Well, you know that PJ is 3 over 7 times 4, which is 12 over 7. So we know that FJ through Pythagorean theorem is, so FJ is going to be 6 root 5 over 7 squared is 36 times 5, which 36 times 5 is 180 over 7 over 49 minus 12 over 7 squared, 144 over 49. So this gives us, 180 minus 44 is 36. So this gives us 6 over 7. So FJ is 6 over 7. Okay, so now we need either FI or IH to find out JI. So let's see if we can find FI. Well, we know that, okay, so let's see. So how do we find FI though? We know that FI is inside triangle FIQ, but FIQ, we don't really know the ratio of the sides. That's what we want to find out. And how did we actually find out the ratio of PF to EF in the last part? Because we knew that AEP was similar to FPC. So maybe we can create some similar triangles since we already have AQE and this part. So maybe we just need a similar triangle. So let's try and extend AG and DC so that they meet. Let's call this point HIJK. Let's call this point K. Now through similarity, through parallel lines, we know that alternate interior angles are equal. So this angle and this angle is equal. And we also know that opposite angles are equal. So through a similarity, we know that triangle AQE is similar to triangle KQF. Okay, so if we know that that's similar, then now we again need the ratio of the sides, right? We want the ratio. So let's try find the ratio. Okay, so let's see. So for AQ and Q, so we have EQ and QF, AQ and QK, and AE and FK. So which one is easiest to find the ratio of? Let's start from AE and FK because they're parallel to each other, I guess. So we know that, okay, so we know that through similar triangles that so we know that GCK is similar to EFH. So why is GCK similar to EFH though? Okay, so let's try and prove that. Well, first of all, what do we know? we know that these angles are equal. And we also know through parallel that these two angles are equal. So we can also prove that angle ABG is similar to triangle ABG is similar to triangle KCG. Okay, so what this tells us is that the ratio of BG to GC, which we know because in the problem it specifically says that CG is 1, and so BG is going to be 3. So the ratio is 3 to 1. So that ratio is going to be AB to CK. So if that ratio is AB to CK, we know that AB over CK or CK over AB is 1 over 3. So this means that CK is 1 over 3 times 5, or 5 over 3. So since CK is 5 over 3, and FC is, FC is 3, we know that FK is 3 plus 5 over 3, which is 14 over 3. So that's 14 over 3 there. So if FK is 14 over 3, we therefore know that FK to AE is 14 over 3 over 4, which is 14 over 12, which is 7 over 6. So if FK to AE is 7 over 6, we know that therefore FQ to EQ, so FQ to EQ is also 7 over 6. So if that is like 7 over 6, then we can easily figure out both FQ and EQ. So if we figure out both FQ and EQ, we can figure out PQ because we already know PF. So if we figure out FQ, then FQ minus FP is PQ. So the answer is out. So let's find FQ then. FQ is going to be 13. So it's going to be 7 over 13 EF. So why? Because we know that this entire thing is, we know that EQ is 6x, FQ is 7x. So 7x plus 6x is 13x. So that's 7 over 13. Now EF is 2 root 5. So this means that FQ is 14 root 5 over 13. So if FQ is 14 root 5 over 13, then we know that PQ is going to be, PF is 6 root 5 over 7. So we have 14 root 5 over 13 minus 6 root 5 over 7. Yep, so if we calculate that, which is again a bit messy, so let's zoom in and calculate that. So 4 times 7 is 8, 28, 1 times 7, so that's 98. Root 5 minus 6 times 13 is 78 root 5 over 91. So that gives 20 root 5 over 91. So if that's 20 root 5 over 91, then we know that PQ over EF is going to be 20 root 5 over 91 over, EF is 2 root 5, right? Okay, so the root 5s cancel out, and 20 and 2 cancels out, and this is 10. So the answer is 10 over 91.